What is data clustering? Data clustering is an unsupervised machine learning technique that groups similar data points together while separating the similar ones. The goal is to discover natural patterns, structures, and relationships within data without prior knowledge of categories or labels. It's widely used for customer segmentation, image analysis, anomaly detection, and exploratory data analysis. First, we have Fuzy C Means, which required us to specify the number of clusters, and based on that and the distribution of data, calculates the cluster centers, and based on the distance from each point to the center, determines the relationship of that data point to our cluster. The key insight here is that data points don't always belong just to one cluster, as we can see here. The different colors represent the relationship to that point to the data cluster. Here we can see that we have ambiguous points. This shows that maybe this data point is related in a certain percentage to one cluster or the other. Now let's look at Gaussian mixture models. It works quite similar. Also, we have to determine the number of clusters that we need, and based also on the center and the distance of each data point to the center, determines the relationship of that point to the cluster based on a normal distribution. Like we can see here, these elliptical rings, the closest ones to the center are the ones on the center or the peak of the normal distribution, and as long as the data goes away from the center, the relationship decreases. Gaussian mixture models considers the shape and spread of natural data groupings. Points near the center have high probability of belonging to that cluster, while points between clusters have lower probabilities. This gives us uncertainty estimates, crucial for applications like medical diagnosis or risk assessment, where we need confidence scores. Both FCM and GMM give us soft assignments, but GMM does it through probability theory rather than Fuzy memberships. Now for something completely different, we have hierarchical clustering. It takes a bottom-up approach, and best of all, it doesn't require us to pre-specify the number of clusters. This dendrogram here is a roadmap. Each leaf is a data point, and as we move on, similar points merge into branches. The height shows how different the merge groups are. So basically what this method does is each individual point starts as a single cluster, and then gets related with the closest point to it, merging in one cluster. This process repeats until the difference between data is big enough to consider they actually belong to different clusters. And here we can see our data separated in 3 different categories or clusters. Now, comparison and conclusion. So when should we use each method? We could use Fuzy C Means when you need to model partial memberships and overlapping categories. like for example customer segmentations, where people might belong to multiple categories simultaneously. We can use Gaussian mixture models when we want probabilistic confidence scores and natural distribution shapes. And we can pick hierarchical clustering when exploring unknown data or when we need to understand relationships at multiple levels. The key difference between FCM and GMM require us to choose the cluster count up front, while hierarchical clustering helps us to discover it. All three are powerful tools in MATLAB's clustering toolkit, each with unique strengths for different data science challenges.